This is Precalculus Concept 8b, vertical shifts. I'm going to start with, we got 3 boxes, we're going to start with the definition. So, if f is a function and c is a positive real number, then the graph of f of x plus c is going to be the graph of f of x shifted up c units. So basically the idea here is that if we have a known graph, like one of our common functions, and I simply add a number to that function, the way the graph is affected is that you see the exact same graph except it's just been shifted up. So every single point on your original function here is going to be moved up by whatever the value of c is. So if c is 2, you're going to shift the whole graph up 2 units. If c is 4, you're going to shift it up 4, and so on. The shape of the graph is exactly the same in every way. It's just been translated or shifted up. And as you might imagine, if you do f of x minus c, you're going to see the exact same thing. You're going to have every single point on the graph of f be translated or shifted down by a magnitude of c units. All right? So adding or subtracting to a function, you're going to end up seeing a vertical shift. All right, box 2 is going to be an example. We're going to ask you to graph 2 functions. One of them is going to be a common function that you learned last lesson, and then your second function is just going to be a common function with a small change to it. All right, so we're going to look at the graph of f of x equals the square root of x, and then I'll use a different color here. We're also going to look at g of x, which is a different function, but obviously very closely related, and think about what those 2 graphs would look like. Okay. We're also going to ask you to help show those transformations to kind of think about 3 points on each graph. Alright, so I'm going to start with the square root function. You should have a pretty good idea of that from our last lesson. I'm going to pick a couple points here. 1, 1 will be a point on that graph. 4, 2 will be a point on that graph. And 9, 3 will be a point on that graph. Alright, we should remember that the square root function kind of looks like this. And I'm going to label those points. So I've got 9, 3, I've got 4, 2, and I've got 1, 1. Okay. So what you should understand from our definition is that if I'm looking at the same exact function, but I just have square root of x plus 2, that every single one of these points is just going to be moved up 2. So there's really no need to do any more calculating because I can just think about this in a very visual way, and each of these points is now going to be shifted up 2. What changes in your points is the y-coordinate, right? So instead of 9, 3, you're going to have 9, 5. Instead of 4, 2, you're going to have 4, 4. And instead of 1, 1, you're going to have 1, 3. So I'm finding those coordinates simply by shifting each of those points up 3 units. 0, 0 is another good point to think about here, and that's going to become 0, 2. So your graph's going to kind of start right there. Obviously it's all the points between, but that's what your graph would look like. And so now I have 2 functions that are definitely related to each other. They're exactly the same shape, and one is just simply the first one shifted up 2 units. Alright, box 3 is a you try. Again, we have a function that you are familiar with, a common function, absolute value. And then you're going to think about a related function, which is that same function, but this time absolute value minus 3. Okay, take a minute, see if you can do those 2 graphs, and again, see if you can label any 3 points on each graph. Alright, your absolute value function is this V-shaped graph. You might have picked some points different than me, but I'm going to pick a few. I'm going to pick 0, 0 as a point on this graph. I'm going to pick the point 3, 3, just kind of picking ones at random. And let's go over here and do negative 4, comma 4. One thing to remember about absolute value graph is the slope of the graph is going to be the negative 1 on the left, positive 1 on the right, so we can think about that as we graph it. Okay? All right, our second graph is simply a vertical shift of our first. So you're going to take every single point and you're going to move it down 3 units, down 3 units, down 3 units. Okay, over here this point is now going to be negative 4, 1. This point right here is going to be, instead of 0, 0, 0, and negative 3. And your point 3, 3, when you move it down, becomes this point, which is 3, 0. Alright, these pictures start to get a little bit cluttered, but you're always going to want to kind of emphasize your final answer. If you have highlighters or colored pens, that's certainly super helpful in this section. But the green graph here should be the exact same shape as my red graph, but obviously it's been transformed by being shifted down 3 units.